Now let's look at testing for significance. So we already went over testing for significance, which is whether the slope is different from 0. If the slope is 0, then whatever the x value may be, the regression is not going to be different. It's going to be just that constant value. So testing for significance is whether the slope coefficient is 0 or not. If it is not 0, then the regression is significant. If it is 0, then it is not significant. So here the hypothesis is we put the 0 here. Now we need 4 assumptions for us to be able to test this hypothesis, and one is the model assumption, and that is the expected value of the error is 0. So the model assumption here, so here is the model. Given the regression model that y is equal to beta sub 0 plus beta sub 1x plus error, the expected value of the error is 0. So that's our model assumption, first assumption. Okay, and the second one is, so the variance of the error term is all the same no matter what the x is. So by x changing, the variance doesn't change. So that is something like, if you look at this graph, as x changes, the distribution has the same range. It doesn't have, if x changes and the width of the normal distribution varies, when x varies, then this assumption will not be true. So for this assumption to be true, for all values of x, the variance of E remains the same. The third assumption is the error terms are all independent. So that is, as x changes, the value of the error doesn't, it's not dependent upon x. So if x increases, if the value of the error increases. If the x goes down, the value of the error changes, then that would be dependent. And finally, that the error values follow normal distribution. That's what we saw in the picture, like this. So these are normal distributions. So given these 4 assumptions are true, we can test this hypothesis, and let's assume a 5% level of significance. We can either use the formula or the regression output. So formula B sub 1 we have already computed, which is using the formula right here. Okay. Now S sub B sub 1, the formula is given by, so this is the formula for S sub B sub 1, and the S here is the square root of mean square error, and this denominator is the square root of the denominator that we used here. See, this is the same denominator that we used to compute B sub 1. So if we take for S sub B sub 1, okay, and we have to do a square root, okay, if you take MSE, square root of MSE will be S, square root of MSE, okay, MSE divided by the denominator. So that will give us the standard error of B sub 1. Okay. Now B sub 1 divided by S sub B sub 1 will give us the t statistic value, and the degrees of freedom comes always from the error. So that is, degrees of freedom is from there, from the error. Okay. Same information can be found from regression output as well. So if you look at regression output from the data analysis command, here is the coefficient. Now S sub B sub 1 is right next to it. The standard error is the standard error of S sub B sub 1. The S sub B sub 1, the standard error is right here. Standard error of the B sub 1, that's our S sub B sub 1. And of course, when you divide B sub 1 by S sub B sub 1, that will give us the t value, but in fact, the t value is also available in the regression output right here, the t statistic. And it gives us the p value also alongside. Okay. So now we can use t table value approach. So t table value will be t dot inv dot 2t. Okay. And probability is your alpha value and degrees of freedom is 8. So that will give us the t table value, and since the t calc value, which is right here, is greater than t table value, we reject the null hypothesis. That's our conclusion. Now p value, so that will be t dot dist dot 2t. Now we need to use the absolute value of t. Sometimes t can be negative, so we need to use the absolute value of t, okay, and then the degrees of freedom. Okay. And now that gives us the p value, and of course that p value is the same as the p value that Excel finds, which is again, change the, and you see it is the same p value like that. And therefore our conclusion is, since p value is less than alpha 5%, we reject the null hypothesis. Okay. So our interpretation is that we have sufficient sample evidence to conclude that the regression is significant. And the probability that that conclusion is in error, the type 1 error, is 0.0025%. 0.0025, let's change that to 0.0025%. So we have sufficient sample evidence to conclude the regression between quarterly sales as the dependent variable, as the y, and the size of the student population as the independent variable, or as x, is significant. So the probability that this conclusion is wrong is 0.0025%.